Lightning flashes in the sky, creating a sudden spark of electricity. One of the most powerful phenomena on Earth, lightning throbs with several 100 million volts of electricity. Although lightning bolts are less than 2.5 centimeters wide, they are capable of heating the air around them to 30,000 degrees Celsius. That's 5 times hotter than the surface of the sun. At any given moment, there are 2,000 active thunderstorms on the planet. Lightning strikes Earth between 50 and 100 times a second. There is definitely electricity in the air. But while lightning is beautiful to watch, it can turn deadly if you're in the wrong place when it strikes. Scientists are not yet able to accurately predict where and when lightning will strike, but they do know that it usually strikes tall, pointed objects such as trees and buildings. That's why so many buildings have lightning rods on top of them. Lightning rods are made of highly conductive metal that provides a low-resistance path for the electricity. When lightning strikes, a wire attached to the lightning rod carries the electricity safely to the ground. A lightning display is an awesome sight, but it is safer to admire it from a distance. What is the function of a lightning rod? As you watch this segment, think about what causes lightning and what path it follows when it strikes Earth. Lightning is one of nature's most beautiful and powerful displays. It is a spectacular example of static discharge. But much is still not known about it. To understand lightning, it is important to first learn how it forms, and that begins with thunderclouds. Thunderclouds form when moist air from Earth rises. As the moist air rises, it cools, and as the temperature drops, condensation occurs, producing drops of water. The droplets are pushed upward to the top of the cloud and spread horizontally. Thunderclouds are able to reach heights of 10 kilometers or more, about the same altitude that some passenger jets fly. Fast-moving winds reaching speeds of up to 30 meters per second help to expand the thunderclouds upward. These winds cause the water crystals to be in constant motion, resulting in lots of tiny collisions. These collisions cause the upward-moving particles to lose electrons, giving them a positive charge, and resulting in the top of the cloud acquiring a positive charge. The lost electrons gather at the bottom of the cloud so that the bottom of the cloud acquires a negative charge. Eventually, the buildup of electrons and resulting negative charge at the bottom of the cloud becomes so intense that electrons at Earth's surface are repelled by it and are forced deeper into the ground, resulting in a positive charge on the ground immediately below the cloud. When this happens, electrons in the negatively charged cloud jump to the positively charged ground, resulting in a spark, lightning. Only about a third of all lightning strikes occur between the cloud and ground. The rest occur within and between clouds. But how is the bright spark of light we see created? A lightning bolt starts when the negatively charged underside of the cloud sends a stream of electrons downward in a jagged path. As the negative stream approaches the ground, an upward positive discharge starts from Earth, which is very difficult to see. As the two charged streams come together, they create a pathway for a powerful electrical current to begin flowing. That's when lightning occurs. This discharge of current is nature's way of trying to neutralize the charge separation between the cloud and Earth. And why does thunder coincide with the flashes of lightning? The air around a lightning bolt is superheated to about 30,000 degrees Celsius. This sudden heating causes the air to expand faster than the speed of sound. The expanding air cools, then contracts. Quick expansion and contraction of air around lightning starts molecules in the air vibrating back and forth, making sound waves. Although we know how lightning forms, we still cannot predict where or when it will strike. But the scientists at the Langmuir Laboratory are working hard to change that. Atop Mount Baldy in New Mexico, at an elevation of almost 3,353 meters, this lab is in an area with some of the highest occurrences of lightning in the United States. Here, scientists take advantage of the electrically charged location by triggering lightning and attracting it to hit specific spots. They do this by launching rockets into a lightning cloud that has such a high charge that lightning is unavoidable. When the rocket is struck by lightning, a charge follows a wire that is anchored to the ground. The wire serves as the pathway for the lightning bolt. From this research, scientists are trying to learn more about lightning, how to predict where and when it will strike, as well as arrive at a deeper understanding of the full scope of its power. Until then, it is best to admire these powerful bolts from a distance, while scientists continue to try to understand this beautiful phenomenon. What electric charge does the bottom of a thundercloud have?